Welcome to Golden Software's video training for Surfer 11. Surfer is a versatile gridding, contouring, and surface mapping software package. In this demonstration, I'll be covering gridding XYZ data to produce a grid file. Grid files are necessary to create 8 of the 11 map types in Surfer. You can download grid files from the internet such as USGS DEM files or SRTM data. You can produce grid files in other software, such as ESRI products, or you can create grid files directly in Surfer using an XYZ data file. To grid the data in Surfer, the data file must be organized so that X, Y, and Z data are in 3 separate columns, and it must be saved in a supported data file format, such as a text file, a CSV file, a database file, or an Excel spreadsheet. Click Grid Data, select demogrid.dat, and click Open. In most cases, the default gridding parameters are suitable. However, you can fully customize your grid. In the Data Column section, you can specify which columns in your data file are the X, Y, and Z columns. If you have duplicate data or wish to apply a data exclusion filter, click the Filter Data button. You can tell Surfer to keep the first data point and discard the other duplicate data points, or you can choose to average the duplicate data points. You can also specify the tolerance for what Surfer would consider a duplicate data point and exclude specific data. To exclude all data points in the data file with a Z value of -999, enter Z equals -999 in the data exclusion filter and click OK. If you don't remember which columns contain the XYZ data, or need to refresh your memory on the data, click the View Data button to view the data. Close the View Data window by clicking on the red X in the upper right corner of the window. If you wish to create a statistics report about your data, click the Statistics button and a data statistics report will be generated. Close the report by clicking on the red X in the upper right-hand corner. If the Grid Report checkbox is checked, Surfer will generate a report after gridding with information about your data and the grid file created. Surfer offers you a choice of 12 gridding methods. What you choose for the gridding method will depend greatly on your data and what you would like the output to look like. There is no one best gridding method to use for all datasets or for any particular type of industry. However, there are some instances where some gridding methods may be more suitable than others. The default gridding method, kriging with a linear variogram, was selected as a good method as it produces a good-looking map for the majority of datasets. However, it is not an exact interpolator and can extrapolate grid values beyond your data's original Z range. If your data goes from 0 to 100, the Z range of your grid file may be -5 to 105. If you wish to use a more exact interpolator that does not extrapolate Z values beyond the range of data, you can try the inverse distance to a power, natural neighbor, nearest neighbor, or triangulation with linear interpolation gridding methods. If you like the look of the map produced with the kriging gridding method but wish to include a fault file, then minimum curvature might be the best option. If your data is already on an evenly spaced grid, you might want to try the nearest neighbor gridding method, setting the grid spacing to be the same as the same spacing of your data points. I will choose inverse distance to a power. There are many reasons why you might want to choose one gridding method over another. Each map will look slightly different with each gridding method and is really up to the personal preference of the user. Once you have selected a gridding method, you can access additional options for the gridding method chosen by clicking the Advanced Options button. The options available under Advanced Options will change depending on the gridding method chosen. Some of the more common options include a general page that has gridding method specific options, and in some cases an anisotropy section which allows you to specify the ratio and angle for a preferred orientation in the data. The search page controls which data points are considered by the gridding operation when interpolating grid nodes. If you have fewer than 250 data points, usually the no search option is the most appropriate and the gridding algorithm uses all the data to calculate the grid node Z values. If you have between 250 to 750 points, then the default is to use search, but you will still have the option to specify no search if you want. If you have more than 750 data points, you must use a search. The search rules define the number of data points to include when interpolating a grid node z-value. The search ellipse defines the shape and size of the searchable area around each grid node to calculate that grid node's z-value. Data points that fall outside the search ellipse for a grid node are not considered when calculating that grid node's z-value. If no data points fall within the search ellipse, then that grid node is blanked. The break lines or break lines and faults pages allow you to include a break line or fault file when gridding data. The break line and fault lines must be saved in BLN format to use during gridding. Some gridding methods support break lines, some support break lines and faults, and some do not support either. Break lines occur when there are changes in slope on either side of the line. This might be at the top of a ridge or at the bottom of a riverbed. Break lines have x, y, and z values for each vertex in the line in the BLN file. This is the only time when z information is used in a BLN file. Surfer can look across the break line to the other side for data points to use when calculating grid nodes. The XYZ points of the break line BLN file are also included as data points during gridding. Faults occur when there are differences in z values on either side of the line. This could be because of a geological fault or another reason, such as a landslide. Faults only have x and y values in the BLN file. Surfer sees the fault as a stop when gridding. It cannot look across the fault to the other side of data. It can go around the fault, but the distance will increase and the data on the other side of the fault will have less of an effect on the grid node values. To select a break line or fault file, simply click the yellow open folder icon. Select the BLN file and click Open. Adjust any of the advanced options you wish and click OK. Click the Cross-Validate button to perform cross-validation on your data. Generally, cross-validation can be considered an objective method of assessing the quality of a gridding method or to compare the relative quality of two or more candidate gridding methods. In Surfer, cross-validation can be used with all gridding methods. You can save the results file by specifying the file name and location in the cross-validation results file section. For details and more information on the cross-validation parameters, please click the Help button to open the cross-validation help page. The Output Grid File section allows you to specify the output grid file name and file path. By default, Surfer will create a Surfer grid file. However, you can click the yellow open folder icon, browse to any file location, type in the file name, and choose any of the supported grid formats to save in. The Grid Line Geometry section allows you to specify the extents and resolution of the grid file. You can choose to set a particular x and y minimum and maximum value for the grid file, which is useful if you are trying to match the extents to another grid file, or if you want the grid file to be exactly a particular size. You can also choose the grid spacing. The smaller the grid spacing, the more grid nodes you will have. A higher number of grid nodes will increase the resolution of your grid and vice versa. Increasing the grid resolution can enhance the accuracy of your grid. By default, Surfer sets 100 grid nodes in the longest direction, then spacing values between directions to be equal, and then calculates the number of grid nodes in the shorter direction. You can increase this number up to 32,767 grid nodes. The more grid nodes you have, the more memory it takes to create the grid file. Check the box next to the blank grid outside convex hole of data to automatically blank the grid nodes outside the convex hole. The convex hole is the outer perimeter of all your data points. Leave the box unchecked to extrapolate the data to the minimum and maximum grid limits, regardless of whether data exists in these areas. When you are finished setting your parameters, click OK to create the grid file. You will be notified when the grid file is created, and, if specified, the grid report will open. The grid can now be used to create maps, calculate volumes and areas, or perform other grid functions. This concludes the video training for gridding data in Surfer 11. If you have any additional questions, please contact Golden Software.